Alright, so here what we're going to start looking at is different parts of probability and things called the counting principle. And it's going to be ways to find the total amounts of different things, which will ultimately play into probability, where the denominator is the total number of possibilities, such as when you're rolling a dice, a normal six-sided dice, that denominator is 6 because there's 6 outcomes. But we'll start off a little more basic with something called the fundamental counting principle. And that's just finding total number of combinations. So it's that if we pick 3 students at random, how many shoes, ties, and collared shirts combinations can we make? So let's say that student number 1 has 6 pairs of shoes. Student number 2 has 8 ties. And student number 3 has 13 collared shirts. The total number of combinations that would come out of this is simply 6 times 8 times 13. Right, and the basic counting principle is just multiplying the amounts of the slots together. Right, and you'll often see me kind of write out little blanks like this of slots that will fill in. So we would have 624 total combinations of shoes, ties, and collared shirts. So 624 different outfits that we could make with these outcomes. This was made by someone who had previously lived in Ohio. So it says, in Ohio, we have license plates with 3 letters. So I'm going to write this here. We have 3 letters and 4 numbers with repeats. So this is going to be numbers with repeats. How many possible license plates are there? And then it said, how many would there be without repeats? There are 26 letters in the alphabet. So here's what this is saying. And states have to think about this when they're making up license plates so that they have enough. So let's first do it if you can have repeats. Repeats would be if you could have the letter A 3 times in a row, where that A is repeated. So there's 26 letters in the alphabet, so we'd have 26 options for all 3 of those slots. And then for numbers, we have 0 through 9, which gives us 10. And if we multiply all of those together, so 26 times 26 times 26 times 10 4 times, so 10 to the 4th, we get a very large number. We get 1, 7, 5, 7, 6, and then 4 zeros. So we get 175,760,000 different license plates. So definitely enough license plates to cover the state of Ohio. Here it is without repeats, though. Same 3 letters, same 4 numbers. There's 26 options at first, but if we're not having repeats, they start to decrease because there was 26 options. You had every letter possible. The next slot, though, you can only have 25 letters available because one of them's already taken. And then for the third one, there's only 24 available. And then it would go 10, 9, 8, 7 for the numbers. So if we do this without repeats, we get a different answer. We'll get 7, 8, 6, 2, 4, 0, 0, 0. So we only get 78 million if we don't allow repeats. Now that's still way more license plates than that state would need. So the state might decide, hey, let's just go ahead and not have repeats just so that, we don't have to, it's just a choice they make to where there's not going to be the same letter on there twice or the same number on there twice. They would know that that would be a choice that they could make if they wanted to, and they would still have more than enough license plates for everybody in the state. So calculating the number of combinations without repeats can sometimes be computed through what's called a factorial. A factorial is represented as, and you may have seen it before, it's an exclamation mark. It's an option in our calculator. If we hit the math button and you scroll to the right to where it says prob, which is probability, you'll select option 4, which is exclamation mark. And here's what it does for us. What the factorial does is it would cover a scenario like this. Say there's 5 slots and we don't want to have repeats, so it'd be 5, 4, 3, 2, 1. Instead of multiplying all those together, we could type in 5 factorial, because 5 factorial is equal to 5 times 4 times 3 times 2 times 1. And you can pause and try this on your calculator. Do 5 times 4 times 3 times 2 times 1, or 5 exclamation mark, and you'll get the same answer. It can save us from having to type in longer stretches, such as how many ways can 20 Derby horses finish a race? Well, there's 20 options for first place, 19 options for second, 18, and then on down it goes. So the answer to this is 20 factorial. Now, if you try this, so I do 20 and then I go over to factorial, we're going to get a very, very large number. It's actually scientific notation. So I'm going to write out what my calculator says, to where it's 2.432902,008, and then it says e to the 18th. So scientific notation, we're going to need to move that decimal 18 spots to the right. So what I'm going to do is I'm just going to put a bunch of zeros here. And I'm going to move this decimal 18 spots to the right and see where it lands. So I'm just going to pause and count here. So when I move that decimal spot to the right, you'll see that the number is incredibly large. I noted where the trillions were, so we go 2 commas past that. There is so many ways that 20 Derby horses can finish a race. And that's why they don't place any bets to where you would guess the exact order for all 20 horses, because it's essentially impossible to do because there's so many combinations. And the reason this number is so large is because it's 20 times 19 times 18 times 17 times 16 times 15. Those are all, large numbers to multiply. Even if you just wanted to do the first 2 spots, the first 2 spots would be 20 times 19. So if you're just trying to guess the first spot only, there's 380. 380 ways just for first and second place. If you wanted to do first, second, and third, that would give you 6,840 ways that just the first 3 places could be. So that's why when we're doing all 20, the number is just super large. And factorials can help us find those quickly without having to type in long strings of numbers. There's more things called permutations. Permutations do have a formula. That formula is n factorial divided by n minus r factorial. And those n and r is going to represent the total number of something and then the amount that we're trying to look at. We can also just do it in the calculator though. And we'll do that by going to math, scrolling to probability one more time. And then once we're in the probability, option 2 is something that looks like this, NPR. Now, if you're on the newer calculators when you hit it, it'll bring you up something like this to where you can type in your numbers. If you're on an older calculator, you'll need to type in whatever number you want first, and then you hit it, and it'll bring up the P, and then you can type in your second number. But you would need to type that in first if you're on your older calculators. The newer ones just bring you up it like that, and you can type in both the first and the second at the same time. So permutations are used if you want to know a specific amount of finishers, and not just any order, but the order matters. For example, how many ways can first, second, and third place happen in the Derby? So we were talking about that up top, just the total number of ways that it can happen. And we saw that it was 6,840. We can do that with a formula of permutations. And what would it look like? It'd be 20 permutation 3. because there's 20 horses, and we wanted to know how many ways can they fill the first 3 slots. And when you type that in on your calculator, and I encourage you to try it, you get the same answer that we had gotten right here. And you might be wondering, well then, Mr. Caudle, what do I want the permutation formula for? I could just have done it like that. Well, if I would have asked you the question of maybe the first 7 finishes, then you would have had to do times 18, times 17, times 16, times 15, all the way down. But I could do it quickly with permutations as 20 permutation 7. So it's a way to do the factorials, but where it's not going to go all the way down to 1, or maybe just a piece of 3, or a piece of 6, or whatever amount of pieces that you want. So that's what this formula is good for. Because factorials, when you use the exclamation mark, take you all the way down to 1. With these, you can select smaller pieces. Now, that's permutations where the order matters, because first place is different than second place, which is different than third place. But here it says, but what if the order doesn't matter? If the order doesn't matter, we choose something called combinations. And that formula is similar and you won't ever really use the formulas. We're going to use our calculators. So it's in the same spot, math, scroll to probability, and then you'll see that it's option 3 of NCR, where N is the total number and R is that amount that you're looking for. So there are 20 people running for office. The top 3 are chosen to represent. In other words, there's no president, vice president, or etc. How many ways can these students be chosen? So this is saying, hey, there's just going to be 3 people that win, but their slots are all just the same. So there is no president, vice president, secretary. We're really just trying to decide how many different ways can I choose a group of 3 out of 20. And if we type that in on the calculator, there are 1,140 ways to get 3 different groups of people out of the class. Now, if we compare that to permutations, to maybe now the 3 slots, you have president, you have vice president, and you have secretary. Those slots are all unique, so that 3 right there matters. And you're going to notice that if we do the same thing, except with permutation, the answer is much larger. And that's because if you think about it, and we had a classroom, so we have some people here. I'm going to draw out 20 people. If we have 20 people, and I'm doing the choose, there's only one way I can choose this group of 3. However, if we're choosing them through permutation, there's different ways. It could be president, vice president, secretary. Or rotate it. Could be president, secretary, vice president. Or it could be vice president, president, secretary. And there's multiple ways that you can do that to get more options out of one group of 3. So that's why the combinations are less, because there's only one way to circle a group of 3. But with permutation, when the slots matter, there are more. If you were to fill out the rest of these, you'd actually find that there's 6 combinations. And if you didn't want to figure out how many there were, you could use permutations. There's 3 people, and we're filling 3 slots. 6. So there's actually 6 ways to pick a group of 3. And so that means the permutation amount ends up being larger. In this case, it actually ends up being 6 times larger, because for every group of 3, there is going to be 6 ways of choosing them. Sometimes the fundamental counting theory can be used to help us reason through a problem without having to use a formula. However, formulas are very helpful. And so what that means is without a formula, when we are doing license plates, we just kind of drew it up. And you can do it with other ways too. Like when we said that there's 26 letters and 25 letters and then 24 letters and then numbers. There are ways to do those with formulas, but sometimes just writing out the number of slots and multiplying it yourself can be helpful. But then the other formulas are helpful too, like when we're dealing with larger numbers such as derby horses or ways to count groups out of 20 people in a classroom. And the important things to remember is if the orders matter, we need to use permutations. So that's like president, vice president, secretary. If the order does not matter, we're just looking for what's called combinations, the total number of combinations. It gets a little confusing when deciding if the order matters or not. Most of the time, the order does not matter for regular choices or outcomes. The best way to think of it is, are the slots you're trying to fill unique, such as president, vice president, secretary, first place, second place, third place? If the answer to that is yes, use permutations. If the answer is no, there aren't unique slots, such as I'm just picking groups of 4 for the classroom, then use combinations.